What questions do you have about this? I mean, I'm not done yet, but I did also email a worksheet that we'll do. So in the other class, we didn't get through all of it, but that's okay. Okay, so let's do this. Oh, we can't. Now I can see it. Good, good. Right, just making sure. All right, so let's do an example. So we already saw the square root of 20, right? We saw that it's not simplified, but we're going to simplify it. I listed the perfect squares here for convenience. Okay, so we know that 4 is a factor of 20, right? We saw that already. That's okay. So next what we do is we factor it out. When you factor it out, right, you know, what do? Well, you have to divide to see what's left over. Although I think most students, from what I saw, know that 20 is 4 times 5. So, but normally you would factor to get the other factor. Then you have the square root of 20, right? That's the square root of 4 times 5. But now you use that property, the square root of a product is the product of, is the product of the square roots. So we have the square root of 4 times 5 is the square root of 4 times the square root of 5. And square root of 4 we know is 2. So we get 2 times the square root of 5. Good. Okay, that's good. Now what about the square root of 5 though? Is that simplified? Well, let's see. The only factors of 5 are 1 and itself. Right? That's what's nice about 5. Its only factors are 1 and itself. And 5 itself is not a perfect square. Only 1 is. So the only factors of 5 that's a perfect square is 1. So the square root of 5 is simplified. So we stop here. Again, when you're simplifying, you know, you stop once you hit something that's simplified. You can't keep going any further is what I'm saying. So that's one example. Good. Any questions on that? Okay. For the square root of 72, this is another one. So we want to know if this is simplified. Well, if you look at the factors of 72, we know 9 is a factor, and 9 is a perfect square, right? 9 is 3 squared. I know you could do 36, but let me just stick with 9 for now, mostly because that's what I have on the slide. So we have 72 is 9. To get the other factor, you divide, which turns out to be 9 times 8. Okay, that's good. Okay, so from here we have 72 is 9 times 8. So the square root of 72 is the square root of 9 times 8, which is the square root of 9 times the square root of 8, right? Square root of 9, square root of 8. And what's the square root of 9? We get 3. Okay, as we saw already. But are we done though? We have to know, is the square root of 8 simplified? Well, it turns out the answer is no. Because if you look at the factors of 8, 4 is a factor and 4 is a perfect square. So the square root of 8 is not simplified. So we have to repeat the process. If we went back to the, here we had to repeat the above if necessary on the remaining square root, said to do that. And that's what we're doing here. We're repeating. Because you might get something that's not simplified. So you want to check if it's simplified or not. We have 8 has 4 as a factor. So 8 is 4 times 2. You know, you divide to get the other factor. And so from here, we get the square root of 8, which is the square root of 4 times 2. That's the square root of 4, times the square root of 2, which is 2 square root of 2. That's what we get. So putting that in, we get 3 radical 8 is 3 times 2 radical 2, which is 6 radical 2. And radical 2, of course, that's simplified. Hopefully it should be easy to see that. That's what we get for 72. All right. Now, what questions do you have about this? Okay. Well, let's do rationalize. So basically here, when I say rationalize, I mean rationalize the denominator. And really to do that means you want to remove any radicals in the denominator. That's what it means to rationalize the denominator. You basically want any radicals in there, you want to remove them. Okay. Now, when I say radical, though, here I really just mean square roots, because that's really the only radical we're dealing with, although the book does deal with more. And we're really going to use this property, that if you take the square root of a and then square that, you're going to get a itself back, where again, a is for any non-negative a. So if you take the square root and then square, you're getting back what you started with. You know, we saw something similar to that earlier. So, right, I think we had before, you square a, then take the square root. You get back a itself. And this is assuming a is non-negative. So again, now I can say the square root and the square, you know, squaring, they do the opposite of each other. So, all right, cool. Okay, now we have b. So here's basically the idea behind rationalizing. If you do b over the square root of a, you want to get the square root out of there, so we multiply and divide by it. Keep in mind, a here is positive. Square root of a is not 0, so this makes sense. Using what's here, we're going to get this. Well, now using it, we get here, this whole quotient equals this. So that's really just the calculation. And this is an example. If you have 1 over radical 2, okay, well, let's multiply and divide by radical 2. Doing so, you get 1 over radical 2 times radical 2 over itself, which is radical 2 over radical 2 squared. Using this property, we get radical 2 over 2. Okay, that's what we get. Good. Okay, here's another one. I think in the notes I might have had the example at the bottom written twice. Sorry about that. 3 over radical 5, same idea. You're going to multiply and divide by the square root of 5. Okay, you want to multiply and divide by that. You want to get radical 5 out of the denominator, and this will pull it off. Because what we get is 3 radical 5 over radical 5 squared. And again, using this property, just like I did here, you get 3 radical 5 over 5. So that is what we get here. Are there any questions on this? Okay, so now I think it's good to do the worksheet. I did email it to everyone. So let me pull it up. Here it is. Okay, let me share it. I mean, I did email it to everyone anyway. What? Nope, wrong one. Here it is. I mean, this is the worksheet I'm referring to. So you should have it in your email. Again, I would let's work on that for about 5 minutes. So let me stop the